I'm Jenny Lister. I'm a Deputy Head Teacher, I have been a Science Lead and I'm a Fellow of the PSTT. Today we're going to be learning about something called biomechanics. That's a special subject focused on the movement of the body. Have you ever wondered what life would be like if you didn't have one of your arms or legs? That's real life for children your age all over the world. Thankfully, there are people out there with skills which they can use to help children, and grown-ups too, who were either born without limbs or lost them in accidents or to illness. Today, you're going to find out what it's like to be one of those people. I'm going to ask you to think about making a prosthetic arm for someone who needs one. You're going to learn a bit about the human body and how it moves, and about prosthetics too, in order to do this. But first, let's hear from a real-life biomechanical engineer about how much of a difference you can make with these skills. Meet Ben. Ben is making a huge difference to the lives of children all over the world. This is Ben and Saul's story.
Saul is my first child. He was born in 2015 and he's the light of my life. It was a normal healthy pregnancy, but we think that during the forceps delivery that the forceps crushed the artery in his left arm. Sadly, by the time he was taken to a specialist unit in Alderhay, it was too late, so he had to lose the arm. My name's Ben. I'm the CEO and founder of Ambionics, and I invented body-powered hydraulics. So I started on my phone from the hospital researching amputation, amputees, prosthetics, and I noticed immediately there was a pattern of rejection in children who didn't receive a prosthetic or a functioning prosthetic early enough, and that just inspired me. And I just remember thinking, that's not going to be my Saul. And it was actually one night, I think it was 2 in the morning, and I was thinking through that I saw a spider on the roof, and I remember seeing that spiders use hydraulic pressure to actuate their legs. A fluid solution jumped to mind. It was like a eureka moment. I printed these, which are PVA soluble casts. If you can see the fluid that I'm going to fill with, which would be polyurethane. So print them in that position, and then there's a cavity inside which is filled with liquid polyurethane, which is very cheap and incredibly strong. And 8 hours later, after you've chucked it in water, you can produce this. The idea being that it'll go under the arm. As Saul squishes it, it'll extend or retract the bellow with a spring on the end of it and just open and close the thumb, which is incredibly simple. But to get to this point where I can make them has been an epic journey. I can now create sockets that fit perfectly. So from receiving a scan now from a child anywhere in the world, I can model a socket in about 20 minutes to 40 minutes, depending on, because every child's different and every shape is different, but I'm getting faster and getting better. I want to keep affordable arms available to families who perhaps around the world don't have access to a prosthetist. So I would like to be able to set up Ambionics in every continent. When I see Saul using just his passive, non-functional arm, and I see him using it intuitively, I just lean down and scratch his leg with it. So I thought, even if this all stops now, I think I've managed to bridge that gap. I wanted to show the world is that this wasn't just something that I'm working on with my son, that I could quite easily help other children. I'm eternally grateful for the support we've had. I received 15 kilograms of filament, which is enough to do the entire beta trial and most of my prototyping. But to just have somebody look at it and say, that's, you know, that needs a pat on the back, that needs some acknowledgement, that was really, really motivating for me.
Now think, if you were in Ben and Saul's shoes, how would you go about making a difference? Let's find out together. These lessons will explore some of the things you will need to know to be a prosthetist, like Ben, and help a child like Saul. You never know, you could one day use these skills to make a big difference in someone's life. If you want to find out more about biomechanics, or to look at other ways you can use STEM skills to make people's lives better, this is the website to go to.